Hello everyone, I'm ghassanSaliby, a master student at VUB University. This video is about pools and lanes as structuring elements of business process modeling notation, BPMN. I will try to answer some questions about them, such as what are they? What are they used for? What do they represent? What do they contain? What are the rules to use them? And finally, in which cases should we use several pools or a single pool with several lanes? But why do we use BPMN at the first place? Business Process Modeling System helps the organizations to improve business processes with the help of analysis and automation. These techniques and methods are often used to identify, model, analyze, modify, improve, and standardize the business processes with the help of automation. So what are pools and lanes, and what are they used for? A pool is a graphic container drawn as a rectangular region, drawn horizontally across the diagram or vertically down it. A lane is a subpartition within a pool and extends the entire length of that pool. Pools and lanes are used to denote a participant in a process and acts as a graphic container for a set of activities taken on by that participant. So the activities can be organized and categorized. A high-level view of a service-enabled process that can be understood by all stakeholders is provided. And the main goal for using pools and lanes that they allow the viewer to be able to differentiate between sections of BPMN diagram. What do pools and lanes represent? Pools represent a participant in a process, so they can be named as business entity. For example, an organization, a company, or a department, or they can be named as a business role, such as the buyer, the seller, the shipper, and so on. Pools can represent an entire business process, and we name them with the name of the process, such as order process, sale process, payment process, registration process. They can also represent other things, such as a function, something that the organization performs, like marketing or sales or training, an application, or a computer software program, a location, for instance, a physical location in the company, a class, like a software module in an object-oriented computer software program, or an entity representing a logical table in a database. We can divide the pool into lanes to represent a business unit departments within a company or role within a business unit. In other words, lanes are used to separate the activities associated with a specific company function or role. Lanes can be nested, so we can create lanes into lanes to represent a hierarchy of a business process. So what are the advantages of using pool and lanes? By taking processes and placing them in pools or lanes, we are specifying who does what. For events, we specify where they occur, and for gateways, we specify where decisions are made, or who makes them. Pools and lanes contain the sequence flow to show the order of execution of processes in an organization or department. This sequence flow is drawn as a line with a filled-in arrowhead to connect events, processes, and gateways placed within the pools or lanes. BPMN makes a second flow line, the message flow dashed line, available to model ordering of processes between organizations or departments, in other words, between pools. Now we will talk about the rules of using pools and lanes. Rule number 1. Sequence flow may cross lanes. In this example, there is a process to post a job, and it contains two units, the business department and the human resource. The business department will report a job opening, and it will ask the human resources to write the job posting. When it's done, it will be sent to the business department to be reviewed. If the review is okay, the human resource will be asked to publish the posting. And if it's not okay, the human resource has to redo the job posting again. We can notice here that the sequence flow crossed lanes indicating the handover the work. Rule number 2. If several roles participate in one activity, create a new role that captures the duties and responsibilities of the collaborative task. And there are motivations to do so. Activities are assigned exactly to one lane. Replication of the activity would lead to several activity instances during execution. Create a new role is feasible as each person can participate in several roles. For example, we have collaboration among teams, sales, marketing, management teams, and we want to conduct a meeting for them. Instead of creating an activity to conduct meeting within each team, we create a new role, marketing strategy team, to handle this activity. Rule number 3. Activities or sub-processes may not be placed between lanes. In this example, task 3 is placed between lanes, and of course it's a wrong use of pool and lanes. Rule number 4. The message flow are only allowed between pools, not within pools. Here we can notice that there is a message flow between task 1 and 2 in the same pool, and this breaks the rule. Message flows are used only for communication of independent processes, which are in different pools. Rule number 5. Sequence flows must not cross borders of pools. As we see here in this example, sequence flow crossed the border of the first pool to the second one to handle the work, but that's wrong, because sequence flows are used for modeling the flow of an independent process with one pool. Rule number 6. Message flows can cross the borders of lanes, but they must start and end in different pools. In this example, we can see that tasks from pool 1 exchange information with tasks from pool 2 using message flows. Rule number 7. We should not miss a sequence flow for activities within a pool. In this example, a sequence flow is missing between task 1 and task 2. This means we cannot start task 2 even if we finish task 1. After explaining the rules, we will try to answer the last question in this video, which is, in which cases should a modeler use several pools and message flows? On the other hand, which cases are better represented by a single pool and several lanes? It's obvious that collaboration diagrams are useful for modeling the interactions of several companies. However, pool need not necessarily represent companies. Instead, they can also stand for divisions or technical systems. A process that spans several units is usually modeled in one pool and several lanes. But it's also possible to model it with several pools. Each division then has its own pool. And divisions processes use message flows for communication. The deciding criterion for using a pool is whether the process is defined or controlled entirely within that pool. So if we have a company which defines processes that span several divisions, for instance, logistic division, administration division, finance division, and so on, it is suitable to use one company pool with a lane for each division. On the other hand, there may be companies in which all divisions define their own independent processes, such as shipping, marketing, and sales, and they only agree on the information to be exchanged. In this case, it is also possible to model separate pools for the divisions connected via message flows. In other words, if the sequence is entirely controlled by the process, it should be within one pool. If this process interacts with another separately controlled process, this other process is in other pool, and the communication between them is modeled via message flows. Deciding for using a pool and several lanes or several pools becomes harder when we deal with intercompany process. Intercompany process describes business transactions which take place between two companies or more belonging to one organization. Each participating company usually retains the control of its own internal process. Therefore, using a collaboration diagram seems obvious. On the other hand, there are also cases in which it makes sense to model an intercompany process completely with sequence flows inside one pool. In such a case, the pool represents the network of cooperating partners. This is reasonable when there is a very close cooperation and the partners define the entire process together. Examples for such close cooperations are the integration of suppliers in the automotive industry and virtual enterprises. Since the partners work together in creating the process, they share the control over the process. If the partners define their processes independently of each other, this may lead to the following situation. A supplier performs a quality control before shipping goods. When the customer receives the goods, he performs a quality control for the same goods again. If only the collaboration of each partner's individual process are analyzed, it cannot be detected that the same activity is performed twice. If the partners agree to jointly optimize the entire process, a model with one pool, sequence flows clearly show the duplicate work in the optimized process, and only one partner performs the quality control. This, of course, is only possible if the customer can rely on the supplier. This is the end of this video. Thanks for watching, and I hope you enjoy it.